Hello. All right. So it looks like things are running. Take that echo out of my ear. Cool. Looks like our bitrate is a lot lower than it has been. Okay. I can't tell if this is big enough. Probably isn't. I have to think about it. Okay, so I wish I did a little bit more preparation, but this will be the first of probably a few streams for working with the Knurling sessions, which is how do I describe it? Well, Knurling is a library that I started sponsoring, and it was, see if I can just like find their thing. No, come on, Knurling RS. So it's by Ferris Systems. They've been in the Rust space for as long as I can remember, and one of the things that they have been doing is developing the libraries that the Rust ecosystem should use for using Rust and microcontrollers, since that's something that I think that would be a really, you know, if you're using like Arduino, you're using C++, and if you've used that language, or, you know, if you're using Rust and you're coming from C++, then you kind of know the reasons why you'd want to, sorry, crinkling, why you'd want to use Rust on a microcontroller if you want to. So I just opened up the microcontroller itself. Let's see if there's a picture there. Nope. No. Well. And yeah, it looks about the same. So I got as far, I opened it briefly for the first time, or for the second time, I guess, earlier, just to make sure that when I, oh. Hey, thanks for the follow. Oh, no problem. Am I following you? I feel like I should be following you too. No, I was also not following you.
Get extra napkins when you order a hot and juicy quarter pounder.
Can't run that. Can't run that. Oh no. I'm like running a bunch of stuff. Cool. All right. Am I streaming on YouTube as well? I believe I'm streaming on YouTube. I'm using Restream. And I think that I've got it set up to also do YouTube, but was it a couple weeks ago or last week? Someone brought it up to my attention that streaming, or once I, you know, hopefully I'll make YouTube affiliate, or Twitch affiliate that streaming in both places might be against the terms of service for affiliate. Oh, interesting. I don't know why the restream. Thanks for posting that in the Discord. Oh, it's for partner. Either way, yeah. I have been getting some like random follows on YouTube, and that's kind of interesting. Thank you. Yeah, I didn't really have like any hard path to follow, other than I wanted to give kind of the maybe somebody who's not sponsoring the project and is someone who's probably like a little closer to me and experience where like either you've got like absolutely no experience with microcontrollers or you've got like a little bit through Arduino where you probably followed a guide. I guess maybe not just like me because I actually went to school for electronics, but I'm not. It's been years since I've done anything really serious. So I would consider myself to be more of a beginner again at this point. But I started using Rust, and I was like really interested. Oh, auxiliary clause is not live streaming. Affiliate is permitted to start a stream on Twitch. Oh, yeah. So does that mean that using Restream is like one of those technical things around not using Twitch to broadcast? Stuck. Okay, so I think what's the date? So it's technically the third week of October, the second full week. So I've gone through and I've looked at this page and it went out to sponsors. So I've gone ahead and I'm gonna go through it again just because I don't know what's changed since I think on Fridays they go ahead and they update. So I'm gonna work through like a mostly first experience through going through the Knurling books, which I think was meant to be for helping people who don't know very much about microcontrollers, or maybe they know a lot more than I do, and to kind of get hands-on with Knurling. So let's go through that together, ask questions. I probably don't know the answers, but we can explore them together. And if you're interested, you can find this post over by the Fair System guys. And I went and I bought these parts. It probably need to look. It was like a little over 100. Mostly what was expensive was this microcontroller, this sensor, and this screen. And this screen came from China. And it took a very long time to show up. I was like, I got an email from USPS, and it was just like supposedly sitting and waiting somewhere in California for like 3 weeks, and then customs hell for sure. But I think I have everything. One of the things I probably should have done was bought some extras of stuff just because it took so long to get to me. So like, I don't know if I've just got 3 resistors, and there's some chatter in the GitHub issues that the LED, like that perhaps something else should have been purchased. I don't really have very much experience with RGB LEDs. So the actual the nature of like how it was produced on the semiconductor side and how it's wired up, I don't know. So I do know that if it doesn't work, I'll reference the issues and see if someone's figured something else out or can give some help. Yeah, I keep on starting and stopping this whole like I want to get back into microcontrollers business, and ultimately what was the catalyst for really wanting to do all this microcontroller stuff is I've got a literal spool of RGB LEDs that I've been wanting to do something with. Actually, it was building some like permanent Christmas lights or just like RGB lights to install on the house so that I don't have to take them down at the end of the year. And so I was hoping that if I can do it all in Rust, then I can write like a web service to also drive some of the controls for it. So hopefully this is like the beginning of something. I wanted something with some network capabilities, so that way I didn't have to do any kind of crazy wiring or anything like that. So I'm gonna have it plugged in. My intention is to push code. But the LED project that I was describing with the spool would probably be a little bit of like I would be running my own code that would do the driving, and then I would have I'm not sure exactly what protocol I'd be speaking with the board, but the external controller that will tell it what program to run. So it'd have like a random mode or like a strobing mode or something like that. Need a terminal open. Probably on this side of the screen since I don't have the chat. Connect one end of the board, J2. So yeah, I got J2 here. I'm not holding it up at the screen, but this portion on the left side of the board. And then do an LS USB. Excuse me, what's going on? I didn't have it turned on. There's a switch here, which probably they should say to turn the board on. There we go. The lights turn on. I can't see if the light is. So it's working. And then check to see that there's an ACM device. Gonna bump this up. Oh, it didn't, device will show up. Oh, TTY. There we go. And I'm not on a Mac OS, but that's good to have it there. It has several switches to configure its behavior. I wish I can look at that description and look at the board at the same time. There's so many switches here. 6, 7, 8, 9, and 10. So I'm just going to scroll up. Well, I'll just see if I can figure it out. Switch 6 in the top right corner is set to the default position. Is that true? Yeah. Switch 7, which is slightly up to the right center of the board, is set to the default position. What is that? This switch is protected by Kapton tape. Oh yeah, it is. Wonder how well the camera will let me. Kind of catches the light here next to my finger. That's why I couldn't feel a switch. So I'll leave that. Be. Switch 8 is on the bottom left. And that's the switch that I needed to turn on. Otherwise the board stayed off. The switch 9 on the right edge, USB connector. So on to the right of the left edge. The switch to the VDD. Which VDD, I don't know what DD stands for, but yeah, electronics, they've got a lot of conventions. So VDD is usually I'm gonna guess it's like the voltage source, and D would be like a digital source, so it probably means it's coming from like a filtered like either 5 volt or 3.3 volt. And so this came with a battery, and so the reason this switch would be important is if you wanted to tell this board to either use the LiPo, which is one of the switches, VDD, which would just be the whatever its voltage source is, and then USB. So I don't know what VDD is in this case. I don't think it matters. I'm not going to touch it. Everything works. Switch 10 on the bottom left corner and to the right of the 8th switch. Oh yeah, it's also got tape. And so it's set to the off position, which it looks like it. And I wish I had some better light in here. I'm gonna turn on the light one sec. I mean, it's brighter, but it's not better light. I can't do anything about it. Alright, so installation instructions. So I do have Rust installed for sure. Then probe run, a custom cargo runner that you run embedded apps as if they were native apps. Neat. I ran this once before, but I'm going to do it again because I don't know whether or not things have been updated. Okay, so v13 version 1.3. So I'm gonna assume that it's the same. Cargo generate, which I think I've got this installed. Flip link. It's a little inconsistent here. with formatting inconsistent. Oh. Well, I guess it doesn't really have much of a command line interface. Rust analyzer. I've got the VS Code running somewhere. Is it behind everything? Yeah. I'm gonna create a little folder so that I can just work in there now. Access USB devices as a non-root user. libudab, so I don't know if I'm running a Manjaro. These are not the instructions, so I wonder if I can add to the book libudev and libusb. Oh, I don't know how to. I don't care. I'm gonna Google this because I don't know how to use the package manager search. And libusb. Focus. Okay, libudev first. I don't know what this is for. I wish it told me specifically what this is for. libusb dev. I think I already have this too. Yeah. Okay, so I had to install udeb0. I'm gonna write this down. Are these both on the AUR? Yeah, so AUR package is libudev0. I don't even know if this is necessary yet. And libusb. and some UDev rules. I kind of know a little bit about this. Let's double check on the rules that they've got before I add them. So vendor product 1366 and 1015. I don't know what this tag U access is. I don't have this file, so I have to knurling. Okay, so run the following command to make these rules effective. So just udev atom control reload rules. Follow. All right. So on to the hello world. So this is a step-by-step guide. Expand the hello in the example hello in the Knurling app template. So maybe I should clone this. Expand the hello RS in the template. Okay, so here's hello. I'm gonna make this both larger and I'm gonna wrap. Bring the following modules into scope. The NRF 52840 HAL crate is a hardware abstraction layer, which helps us access the board's resources. The GPIO pins or timers. If you want a different microcontroller, you'll need to gain access to a timer peripheral. Pins for the onboard LEDs and level of pins. Oh, Lord MT MZ TZ. Sorry. Hello. Nice to see you again. Oh, this is no. Today it's the Knurling board, which is this Nordic semiconductor. This is for the Knurling session book. Never heard of that before. Yeah, it's not a big deal. One of the things that Nordic has in the like microcontroller ecosystem is some nice Bluetooth stuff. I don't know exactly why this board was chosen, but I have like a small amount of experience with this board from my last employer. They had some hardware stuff that kind of gave us some work with it. It was fun. Rust on the Arduino. No. What ended up happening, and as I dug into it, was that there's actually a bug that was introduced into Nightly a while back, and what I ended up running into was something that I ended up finding an issue that was opened like last week or a little bit before I got to it, that pretty much was saying seeing the exact same stuff that I was seeing, where wasn't able to finish compiling. So I felt a little better about that, but also it's not a resolved problem, which is the main reason why I decided to move on to the Knurling stuff before it like it seems like this book itself is still getting a lot of work. So I thought that I would be slow to get through it, and I am. So I'll jump back and forth between boards as I hit the end of one of them. No, you're actually watching me go through this the very first time. So, you know, I just like to struggle on camera, I guess. But one of the nice things is this pattern of using the library to use its peripherals, take, unwrap. Like, this seems to be a pattern that the embedded Rust ecosystem seems to be using. No, I don't have Rust running on this board, but right now, hopefully, we'll get this hello world, and I think it's just supposed to blink a light that's on the board, and then I've got some other stuff that I still need to open out of the packaging, and we'll wire an LED and see if I can get that running. Okay, so I added a library for this HAL. Gonna jump into the cargo toml, because I don't think I added it in here. Oh, I'm gonna click on this link here. I think it's gonna jump me further into the book. So I think that this is a little bit out of order. I should do their project setup first. Gonna follow the instructions that they got here. So cargo generate. I'm just gonna call this the Knurling stream. Oh, I guess I'm calling it my app. That's fine. It doesn't matter. After that, there are some to-dos I can grab for the to-do. Yeah, there are a few to-dos. For example, if I have the NRF 2840, which is the 2840, then replace the chip. In the .cargo toml, .cargo config toml, okay, runner. And F 52840 XXAA. Ooh, these instructions still feel rough, so we will get through it together. There's a lot of output here. Right, that's the only thing that matches. Adjust the compilation target. Change this to the last one. Cortex M4F. FPU. And add a library into the cargo toml. So let's get rid of this. Now that I selected the how, fix the import and the source librs. I'm going to start deleting the to-dos while I'm going through it. So you are now all set to cargo run your first D-format powered application. Some examples. Here's the hello world. Let me see if I can do that. I'm just gonna turn it off. It won't let me do it unless I am paying for things. But since we got chat going on, it's fine. Oh, sorry, one sec. Just like the silence is really deafening, but we're good. Okay, so that's what mine looks like. Name. Cargo running this program produces classic hello world output. I'm gonna move to using the terminal inside VS Code so I don't have to have so many windows open. Oh, I usually don't play music. I've just been playing sounds to so I don't even know that I have music to play on my laptop right now. I mostly have it because my partner sits next to me and sometimes she like gets loud enough for the mic to pick her up. Froggo, run. And hello. It doesn't work for me. I mean, it's entirely possible that um that I just had it down low. I'm still kind of getting used to the OBS monitor here. So I think that just based off of the monitor itself, it was probably around like negative 40, maybe 45 dB. So yeah, it would have been really quiet. I have no idea how loud it was. Yeah, I'm mostly like a fan noise person as well. I have to jump to another guide to figure out how to run. I'm just leaving myself some notes so I don't have to go through the VOD and figure out how to give feedback to the Knurling guys. Well, let's see if that actually works. It did not, so I'm going to try to restart VS Code and see if maybe something with Rust Analyzer going on. No, but it's entirely possible that it's still a Rust Analyzer thing. I don't know what I'm supposed to do here. I don't know what to do. Hmm. Here it is. So I don't have that target installed. I'm just looking to see whether or not they asked me to install that target. No. So I think I can do that with rest step. Yeah, okay. Now let's try that again. Oh, just waiting for this. Uh, it failed. Why did it fail? Error while flashing. Uh, all right. I'm I'm gonna jump over into the GitHub issues and see if I'm the first one, which unlikely I'm the first one to see this. Know that. Somebody already added the toolchain instruction. Hmm. Needs to be connected with 2 micro cables. I only have 1. Doesn't say anything about J3. Okay, one sec. I have to go find another USB cable. Plugging the second one in. I don't know that it did anything. Oh, unplug this. First USB cable. And then second USB cable. I don't think that the second one does anything. I guess I don't know whether or not this is a data cable. Try. Okay. I'm glad I didn't set my my sights too high up. Can't even run the very first hello world. Oh, okay. The issue here says that we don't need the two. I don't know how to interpret this error. It's like one of four things happened. What did I do? I hit the reset button. Something different happened. This is hello world and then it crashed. I don't know that. Let me get, do I have the output of the old? I don't think so. Now I can't repeat it. That's fine. Man, I sure wish that I had the output. Kind of a bummer. Would have helped. Okay, hopefully back on track. Does binary setup? I don't even think it's gonna work. Okay, let's try cargo run bin hello. That works now. I don't know exactly what happened. So I'm gonna look at the code. So it runs this hello. And then it exits which it throws this back trace. And there used to be an LED up in the corner that was on. And I'm guessing that now there's no program on here anymore that blinks it, so that's fine. I'm hoping that the next starting from scratch. And it's got all of this in the wrong order. All right, so that didn't tell me anything. Probe run. There's some background. I don't think I need to do that. That's some more conceptual stuff. Okay, so I guess let's try for this external LED, which means I am opening some more stuff. So before you start, make sure you've disconnected power. Do that. Circuit diagram. So I'm opening up the breadboard. I had one, but I didn't want to think too hard. I need 1 sec. This type of diagram neglects the physical appearance of the parts and how the parts are arranged in the physical world. I guess if you don't know, you don't know. I guess I can read this and interpret it. This is like a small, like block diagrams are really big in the electronics world. And so this is a really small description of just everything that all the ports are. It's not all of the ports described. NC, like typically you'd have a little nub for every single possible input, and I'm going to see if I can figure out what section this one's talking about. Yeah, there's the picture here. Yeah, so to be like most correct, this block diagram really, it should also include these headers. So like the VDD, the reset, the 5 volts, the ground. NC it stands for no connect. And so you can also go forward and and like have like a slash, something that shows that like this is an input that you can physically touch it, but it doesn't actually connect to anything. And then dotted lines tend to mean like it's inside something. And then we got the 3 resistors, so it will physically look like this. I'm gonna spend a moment to do that. I guess I gotta open this. Got ourselves a little like RGB LED. I forget how you can tell what's the like the anode and the cathode, and here I guess it would be 3 of one and then like a ground. So usually you can tell the direction of what the I don't want to like commit to this. You double check on whatever, but the like the long end would tell you like it was this part of the LED, I think. Okay. And I need to so these are jumpers from Adafruit and they're all kind of like glued together, but I'm just gonna peel one off. The black one is typically ground. I guess 2. Why did they do that? It doesn't matter. And then just pick out 3 colors. I don't have a green, do I? Yeah, I'm gonna pick out a red, a green, and a blue. Okay, so I got myself 4 wires. I gotta get the resistors out. Okay, I gotta find the resistors first. There they are. So resistors themselves don't have a direction. I remember from school like having to like test on the colors of the resistors. There's an actual code to it, so you can, if you knew it, you can say what the value of the resistor is. It's like kind of like binary, so it'd be like red, red, and then this brown color would be a multiplier. I think that this is, so I'm guessing that would be like 2, 2, and then times 10. Uh, here's the longest leg of the LED is connected to ground. The single leg on one side is the red channel. The other side is green and blue. And if you didn't know, let me wire it and then it'll be easier to explain. I guess I can just look at it. Um, the breadboard itself, they're numbered. These things are numbered, and everything on this side of the breadboard, it's actually wired together. So, just like I guess for the diagram purposes, they have this resistor cross the middle part, which is like a physical like it's like physically disconnected. But what this ends up doing is, here you've got the LED plugged in, and then this resistor bridges this gap, and then we've got the wire here, and basically like this entire line is connected into one, like they're electrically connected. I don't exactly know why they did this ground the way that they did, but on the breadboard here, this entire row, even though that there's these like gaps, but this entire top row is connected electrically, and this entire bottom row is connected electrically. And blue, I guess, is typically going to be ground in this case, and then red would be typically power if you're gonna, or voltage power if you're gonna do that. But I can read it. I am not necessarily going to connect it with 4 wires. I just want to, or 5 wires. Yeah, I just want to use 4. So the LED is in. They said that the longest, double check. The longest is the ground. I'm just gonna put the black wire there now, so I don't forget. And then I don't really explain any of the rationale for why these resistors are here. Mostly as a current limiter. But to be honest, you probably don't need them in this specific case. Just really good practice to do so. Because you can never, well, you can't assume, you shouldn't assume that the internal resistance in the on the board is going to protect your hardware. This thing's really expensive and these are really cheap. So you might as well just deal with that. I'm gonna get the other wires, red, green, and blue. Oh, and this is a new breadboard and it really feels like it because having to put some force into pushing the wires in. Okay, so I'm gonna wire it onto the board and pretty much going to make it look like that, except for the black wire, which will just go. Just have my black wire connected right about here, and it'll go straight to ground. There are two grounds right next to each other, so these are basically the same electrically. They just give you two different spots to plug it into. It doesn't matter which one you plug. I'm trying to hold it. So that's what it looks like so far. So we're all wired up. Let's continue with the book. Okay, so code. Either work from the same file as the hello world. Work on a copy of it. We'll just do it here, it's fine. That's spelled wrong. We assume that you have access to the P0 pins. In the first example, we configured one pin. That one pin was special in the sense that it only gives access to one of the onboard LEDs. We need 3. This build configure. Configure GPI 3 GPIO pins. P0.3, P0.4, P28. Yeah, and it's really typical for things like this to not be sequential. Figure into push-pull output pin. They can explain. I know what push-pull output is. I'm just hoping that they've got it described. So a pin that is configured as push-pull can switch between high and low voltage. So yeah, for like electrical reasons, their operation for something, it's not necessarily, you know, if 0 and 1 can be like when you've got the voltage applied to a pin or not. And then sometimes you can reverse the logic where a 1 might be if you have 0, if it goes to ground, and then it's off when you've got 5 volts applied to it. You might like what do they call it, like a dead man switch is like an example for this, where if it turns off, then activate. So sometimes you'll switch logic that way. Oh, they really just like throwing me out to figure it out. Okay. I guess I am writing code. I figure out how to do that. Oh, GPIO, general purpose IO. These aren't linking to the right place. Hmm. I don't know how to write this code, so I'm hoping that it's here. Okay, so getting access to the resources. On the page, so ooh, jumping all over. Okay, so I have to add this. Okay, so here's the code, I guess. Add this part here. So that's the HAL, the GPIO. I'll dig into that later so that I can like conceptualize what that's doing. Gain access to the peripherals, add this to the main. You need a timer to blink the LEDs. Don't necessarily need the timer, but it's good. It's great that they're teaching it that way. The other way you would do it would be to essentially have a bunch of so like the way that it code, it's if you know assembly language at all, you would need to just like put a bunch of no ops so that way the CPU would take some time um to do nothing essentially, and you would need a lot of them in order to simulate blinking. Like it needs to be long enough that your eyes can adjust to seeing it on and off. So yeah, the timer would probably be great in that case. Switching the light on. It's okay, so this is definitely what I want. Pins 013. I don't know if that's a typo or what. Because 13 is not, it's not one of the pins that I need to talk to. There's a 31, but I'm not even plugged into that. I want to look at the diagram if I can find it. Yeah, 03, 04, and 28. I feel like this is either a typo or it's out of date or something like that. The embedded HAL crate provides generic API access to different resources at the board. Cool. Let's add that. And then in hello RS, or whatever you're using, I am using hello RS. Bring in these things, embedded HAL, blocking delay, output pin. Add a delay to my main function. Run the program. The program ends. Okay. I'm just going to do this. What's this? I missed this. Okay, so I'm gonna walk through this. So we enter the board. It'll say hello world. We'll take access of the ownership of the board, and then we'll create a handle for the pins, create a handler to the timer. We create this LED 1, which is a reference into, it's probably the wrong pin, but P013 on the board, it turns it into a push-pull output, and then it sets it to low, which I think is just going to turn it off. Timer delay for 1,000 milliseconds, so like a second. It doesn't matter here in this case, and then it'll exit. So hopefully I should see the light turn on. I don't think it will turn on, but I think I can adjust. I'm going to plug it in and flash it. I'm going to move the camera to see maybe. I'll have to lift it up. Okay, so it ran to completion, but it didn't turn it on. I'm going to try to change this to 03, and I hope that maybe. Okay, I'm going to pull it high. Still doesn't work. LED 1 on your mic. Oh, LED 1 on my microcontroller. Second, that's why it was 13. What I do? Oh, okay. So 13 is actually the onboard pin. I'm going to run it and I'm going to hold the board up so that we can at least see it blink real quick. It's going to be in this area. Running. Here we go. Cool. Now let's blink the LEDs. Or let's blink this one individual LED. We'll follow this loop. And then we'll LED 1. We'll set it high. And then we'll set it low. So what we'll see here is we'll set the, it'll probably, it doesn't really matter. Effectively, we will see the light blink. It'll be up for a second, then turn off for a second, and on for a second, and it's just in this endless loop. Here we go. So we saw it say hello world, and then it entered this loop, and it's not going to exit. And there we go. Now, how do we make this work with figure this to be push below with the initial state low. So I'm going to see if I can make everything blank. So we've got access to the RGB, and so I'm just going to LED R. I think that should be 0, and then this should be 0, 3, 0, 4, and 2, 8. Okay, I don't necessarily understand how this library works yet, so I'm gonna just use this set high, set low. I don't know what else is in here, but I'm guessing that I would be able to set different levels of high and low. Okay, that looks right. I'm gonna try to load this. We should hopefully see this. Hopefully see this light blink. It did not blink. It's disappointing. I'm looking at the issues because I remember seeing this. Hmm. I'm gonna unplug this real quick, and then I'm gonna look at the instruction or the link to the website to see if there's like a wiring guide, because maybe I don't have this wired properly. Oh, data sheet. Okay, I'm gonna look at the data sheet since, you know, when in doubt. Okay, so there is like a flat side. It goes flat side has the 1, and then 2, 3, 4. So red is on the 1, and then blue is on 3, 4. So they are right to say that the longest one is the ground. Red, blue, green. Forgot that I moved the camera. Red. Oh, shoot, I can't get it to focus. Red, ground, blue, green. Longest one is ground. Now, what did I do wrong though? space this out so it's wire, but I'm having a hard time wiring it. Go into the breadboard, please. Look at it real quick. It looks right. An LED one is blinking. Something's up with this. All right. I guess I'm looking more into why this is probably not working. Are there any issues here? No, that's pretty much the code I got. Oh, what did I do? Hmm. Am I just skirting through it? So into a push-pull output. can't tell if I possibly just can't see it. Seems like it's not working. Hmm. This feels like it's. I want to stay here until this is done, but I don't know. I don't know. I'm feeling stuck. I don't really know where to look into this a little bit more. Like, there's very little code here. Okay. So LED 1 on port 13. We're doing the same thing here. P0, 03, P0, 04, P0, 28. They're setting up there too. And then that's physically connected on the board. I feel like I'm just gonna need something up here. I might play around with setting up another camera for like the future streams. I guess you can see that blinking there, but can't see that. Into push pull output. Everything is set high and then it's set low. And we've got these timers and it should just flicker, blink. I know I didn't imagine seeing complaints about the LED. I just don't remember when. Okay, so there were sponsors chat. Okay, so it seems like the problem is more of the LED itself. It's got some like electrical, like without getting too deep into it. It's just so um I'm just gonna read out loud what it said. If you wire it up like this, but put the common anode to VDD, the page shows the cathode to ground, then it works. So it says bring it to VDD instead of ground. Here we go. Hey, cool. Now I wish I wish that school kind of stuck into me because I don't necessarily know what I needed to do. Shoot. All right. I guess the last thing to try to do is figure out how to um pick like feed different colors into this. So basically, oh, what happened? I think I got a wiring problem. It'd be white. I'm gonna pull wires randomly, not randomly, but one at a time, just to see this force different colors. Cool. Wonder why that's blue. Oh, there you go. It'd be like a mix of green and what is it? Green and yellow? Oh, RGB. I don't know. I'm gonna mix colors in my head, but I think that this is that's right. Okay, now how do I would be really cool is if I could strobe this to be like, kind of whatever color, change it to be like all the way red, all the way green, all the way blue. I guess I need to look up the instructions. So let's see if this is on crates or on docs. Go. P0. Oh, it's the Xenum. Which is lower high. Maybe I'm missing something. All right, so I feel like I'd be happy to. I'm gonna spend a little bit more time trying to see if I can figure that part out. But I got to this part, so I'm real psyched. Live. I clipped it like right when I got it. At a stream. So okay, so I got myself a little stream marker. Okay, okay. How do I mess with that? With switching between different presets of the LED. Quite mysterious. I feel like I don't necessarily know based off of what they've told me how to do. Yeah, these levels are only high or low. It's a floating input. Oh, like disconnected. So, this is a type. Well, they made all of the pins into their own type. That's clever. Input floating. Hmm. Okay, so I don't get it. Well, I think maybe that's enough fiddling around. I'm just gonna have to um take my wins here and we'll see who's online. Let's see who's online. Gosh, I don't know. I can't get it working. Anyway, I am gonna log out for now. Well, if I come up with anything else with this, maybe I'll do some impromptu stream. If I might play around with some of the Arduino stuff again later in the week, but hopefully this Friday there's something new to do on the Knurling side. So cool. Thanks guys for hanging out with me and seeing this win right here. Ooh. All right. Thanks guys.